Hi, Computer Science 1 class. It's Mrs. Miskin. We're going to now go over lesson 22 in code.org on for loops. Now, just a refresher for what a for loop is. It is a loop that has a starting point, a stopping point, and increments by a certain amount in between. So let's go ahead and get started with screen number 1. Okay, this is just going to use everything that we've already learned before. Okay, so collect the nectar from each flower using the fewest blocks possible. So we know that we're going to move and get nectar. There, we'll just do our actions first. And then we're going to loop. We move one, we get one nectar. We move one, we get one nectar. So we can repeat those 2 steps in a regular loop. And how many times do we need to repeat? 1, 2, 3, 4, 5. So in our math, we'll grab a number and put 5 in here. Okay, let's run it and see if that works. Okay, all right, that was easy. We know how to do that. Okay, so now we're going to have to use a lot of blocks because this will change every time. Okay, so write the code to help the bee collect all of the nectar. So we still are going to move one, but we can't loop it like we did the last time because each time the number of nectar that we collect gets bigger and bigger. Okay, so first of all, we would get nectar. Then we're going to move forward again and get nectar, but this time I think we'll probably want to use a loop since we repeat it 2 times. So let's go grab our math and we'll tell it 2 times. Okay, let's just run it to there and see if that gets part of the way through, if we're on the right track. Okay, all right, so we're going to have to keep doing that step over and over and over again. All right, move forward again, grab our loop, and collect. Get nectar, and then we need a math. How many times do we do it this time? 3. Okay, same step again, move forward, loop. Wow, I'm getting a lot of blocks here. There's got to be an easier way to do this, right? Okay. Number block, we're on 4 this time. And get nectar. One more time. Move forward. Loop. Math block for our number. Okay, we're on 5. And we will get nectar. Okay. Let's see if that works now. Okay, so we did it, but it took 18 lines of code. Okay. Hang on, that said that I took 19. I'm just going to double check really quick. Okay. There was probably a way that I could have simplified that. Probably by combining a couple of these steps here. Let's just look at the solution and see. If you'd like to edit it later on, you certainly can. Okay, interesting. So instead of using loops, on the second one, the answer key said to just have to get nectar and get nectar, probably because you use the for loop, the number, and the get nectar, so that's 3 instead of just having 2 blocks. So why don't we go ahead and just edit that really quick? That seems like a very simple solution. Okay, so we'll just move that get nectar out of here. We need another get nectar. And then we'll drag these back up. Certainly don't want to trash them. Whoops, that went into the wrong spot. Sorry, my mouse is being a little bit tricky right now. Okay, so move forward 1, get nectar 1, move forward 1, get nectar 2, move forward. Now we can add our repeats here at the bottom. Okay, now I've got 18 blocks and I'm within that range. Let's just double check. Okay, so you see how even just changing from a loop to using 2 blocks saved just a little bit. Okay, that's because we use the math block in the repeat for the number. Okay, let's go on to number 3, is an explanation of what that for loop looks like. So you have a starting value, an ending value, and then how many you increase each time or decrease in between. So the for loop is also pink because it's a loop. We would start at 4 in this instance, go up to 10, and then count by 2 in between. So in this example, right here, this is very similar to what we just did. We could say start at 1 and then increment or go up by 1 each time because it goes 1 and then 2 and then 3 and 4. So there's 1 in between each one. Then we would end at 7. So in this puzzle right here, our for loop would look like, so here's our counter variable. We've used variables before. Our starting value would be 1. Our stopping value would be 7. And then count by would be 1. Okay, let's go on. Screen number 4 is a video. So go ahead and watch that on your own. And when you're finished, come back to our video and we'll go on. Number 5. All right, this is a look at the code and predict the answer. So this one you're not actually going to be coding, you're just going to read through it and determine what it will do and then just give an answer. Then we'll go on. So let's just take a look. The use of for loops makes this puzzle easier. Read the code below, what will happen. So here's that for loop. The counter variable is set at 1 the first time the loop runs. Okay, so the first time it'll move, it'll repeat 1 time, get nectar. Then after it's gone through 1 time, it goes back up to the top of the loop again. But this time, the counter variable is increased by 1 to 2. So it will move forward 1 time, then it will collect 2. Okay, so we're starting at 1, going up to 4. Look at the puzzle though. How many nectars do we collect on the very last one? We actually go 5, okay? So it's not gonna collect the nectar from the very last one. So let's read our answers here and see if we can find one that matches. The bee will move forward and collect all of the nectar from every flower. The bee will move forward and collect all of the nectar from every flower except for 1. Okay. The bee will move forward and collect 1 nectar from every flower. Now we know that our counter variable will increase each time. So I'm going to guess 5 on, or sorry, B, because it doesn't go to 5 on this one. Let's run and see what happens. Okay. All right, so you see how just reading through the code will help you understand what it's going to do to make a prediction like that. Okay, let's go on to number 6. Help the bee collect all of the nectar. Okay, this looks really familiar, right? All right, so let's grab that new block, this for loop. And let's set our numbers here. So we're starting at 1. We're collecting 1 nectar the first time. Then we're going to end at 7. So here's our starting number 1, except we're not going up to 10. We're only going up to 7. Okay, and do we count by 1 in between? Yes, because there's only 1, it incrementally goes up. All right, so the first thing that we would do is move forward. And then, just like in the example that we saw on screen number 3, we're going to grab a loop. And instead of putting a number in here, we're going to use our variable because it's going to change each time. There's our variable counter. And then we'll get a get nectar. Okay, let's see if this works. Okay, hopefully that helps you understand how the for loop is going to work. That one was a simple one. I'm sure it's going to get a little bit more complicated each time, and that's okay. All right, so this one, we're going to do the opposite. This one, we're counting down instead of counting up to collect. So we're going to use a for loop, and we're going to use those same steps. Okay, but we're counting down from 5 to 1. So our starting is 5, our ending is 1, and then we're incrementing by 1. And the increment or decreasing, increase or decrease by 1, it just depends on the pattern here in your starting and ending value. So let's hit OK. We want to start with a for loop. That sets our variable. Now, when we've done variables before, we have to set the variable value before we start the loop. Like we would usually say set counter to and then give it a number. This for loop right here does that in the same step. So it sets the counter variable to a beginning value here as 1. But this time, in our example, we want to set it to 5. Okay, and then we're going to end at 1, counting by 1. So there's 1 in between each one. Okay, so let's do those same actions again. Move forward, loop, repeat, but use our counter variable, not a number. And get nectar. Okay, let's run it. Okay, so it works going up and going down. Let's look at puzzle number 8 now. The last number in your for loop is called the increment. Each time the loop is run, the counter variable changes by the value of the increment. Now this one we're going up by 2 instead of 1 like we have in the previous examples. Okay, same sort of steps. We're going to do this just the same way that we have and change our increment value this time. So here's our for loop. Our variable counter starts at 1. Is that correct? The first time through, we need to collect 1. Our ending value is right here. We end at 7. So let's change this to 7. And then this time we're counting by 2, not 1. Okay, same actions. Move, grab a loop, grab variable for counter, and get nectar. Okay. Okay, that works just the same way as the other ones, as long as we have those values starting, ending, and increment correct. Okay, number 9. All right, so our increment is 3, 6, 9, 12, and 15. There's a pattern there, right? Okay, so let's just start with that same set of steps. So for loop, we're going to start counting at 3. So let's set our beginning value here to 3. And then we end at, the last one that we collect is 15. So we'll go from 3 to 15. Now we're not incrementing by 1. What is the difference between 3 and 6, and then 9 and 12 and 15? Okay, we're counting up by 3. So let's change this one to 3. All right, and our steps are going to vary just a little bit here because we're doing a stair step pattern instead of just a straight move across. So stair step first, we will move, then we're going to turn. And which direction do we turn, right or left? I think right. Let's give it a try. Then we would move again. And then we would turn again. But this time, let's try left. Now we'll use that same loop for collecting nectar and pull in the counter variable. Okay, so these steps will stay the same. They're not increasing or decreasing. The bee will go down a step, forward, turn, down, turn, and then collect, and then it will start over again. So let's give it a try. Okay, very good. Now a couple of differences. If you wanted to run the loop to collect, to get nectar before you did that last turn, you can also do that. There are a couple of different ways that that could be solved, but those would be the same steps each time. Number 10, use the counter variable twice to solve this puzzle. Okay, so let's step through this. We're going to move 1, then we're going to collect 1. We're going to move 2 and collect 2, then move 3 and collect 3. So we'll need to have a loop around our movement and our collecting. All right, so let's start with our for loop. Our starting value, we're going to collect 1 and move 1 the first time. So we can set counter to 1. What do we go up to? 3. So let's change our ending value here to 3. And then do we increase by 1 each time? Yes, we're going from 1 to 2 to 3. So this time we'll have 2 loops. I'm just going to grab them both out right now. And we'll use the variable counter in both of them. And we'll want to move first and then get nectar. So we put move and get nectar. So let's kind of walk through this. First time, even if it's 1, it's okay to put it in a loop like that because it will save us code later on. So we're repeating it 1 time, move forward, repeating 1 time, get nectar. Second time through the loop value, the counter value, the value for the counter variable, say that 10 times fast, it goes up to 2 because it increases by 1 each time. So let's see if this will solve the puzzle. Okay, and remember, if you want to see how that goes through slowly, you can use this step and it'll go through it 1 line at a time. Then you can even see where it's at in your code too. All right, that's number 10. Number 11. Okay, so this is the same, not quite the same code that we had last time, but it has the code for you. Let's combine the counter variable. Hang on. Let me just start over. It looks like I actually did that one once before. Okay, probably did it to help out someone in my class. So let's start over. Let's combine the counter variable with a math block. All right, so we know how to change variable values with math, but let's look at the pattern here. There is a pattern to both things. So let's see what we would need to do. First of all, we would need to turn. Which direction? Let's try right and see if that gets us in the right direction. No, okay, so we want to turn left first. All right, then we would need to move. And we would need to get nectar. Okay, so it looks like that's probably our basic steps each time. In our for loop now, we're going to move 1 time, collect 3. We're going to move 2 times, collect 6. Move 3 times, collect 9. Do you see the pattern that's developing here? Okay, instead of incrementing by a certain amount each time, it's actually multiplying. Okay, that pattern, 1 and 3. Okay, 3 times 1 is 3. Okay, then we're going to move 2 and we get 6. 2 times 3 is 6. So we're going to multiply by 3 so that we can get the nectar. Let's grab our for loop then. And I'll put it right here. We'll just move these blocks inside. Okay, so our counter, do we want to set it to follow the movement or to follow the nectar?
Just a reminder about the meeting today at 11:30 in the auditorium. If you could please
There's a teacher meeting
be down
today.
there and
Sorry
ready
about
to
that.
go by possibly 11:25. Also, try not to sit too close to each other. Thank you.
Sorry for that interruption. Okay, so let's go ahead and get finished on this one. You can do it 2 different ways. You can either start the counter with movement and go 1, 2, 3, 4, and 5. Or you can start with the nectar and do 3, 6, 9, 12, and 15. You just need to use the math block in one of those repeat loops to adjust the value of that counter. Okay, I'm going to have it go with the movement, but you can do it the other way if you want to. So I'm going to grab out our repeat, and we would put move in there, and then I'll grab out another repeat for the get nectar. Okay, so the first time through, because I'm setting it at 1, oh, sorry, we want to go up to 15 because we're looking at the movement on this one. If you want to do the nectar, that's fine. Okay, you'll just have to have some different values in your counter. And maybe we'll do that. I'll just illustrate it when we're done. Okay, so 4 starting at 1, then we move 2, then 3, then 4, then 5. So our ending value is going to be 5. And for movement, we increment by 1. So we would repeat counter times for the movement, but we need a math block for this other one right here. And we're going to take this one out because it's based on our counter. So grab your variable. So this, remember, we move 1, we collect 3. So it's a multiple of 3. So you select the multiple, the times symbol right here, and then just type in 3. Okay, so let's run it and see if that works. Okay, I'm going to hit the replay so that you can see the other way of doing this. If we were to do our counter variable in matching up with the nectar, so we would reverse these things right here. We would start at 3. We would go up to 15. We would increase by what? We start at 3, then 6, then 9, we increase by 3. Okay, so now we're going to reverse these right here. The math block would need to go in our move, and the counter would go and get nectar, okay? Because it's still going 3 and then 6 and 9 and 12 and 15. So now instead of multiplying, we would actually divide. So we're reversing it. We would divide by 3 because the first time through counter is 3. 3 divided by 3 is 1. Okay, the next time through it's 6. 6 divided by 3 is 2. So you see that pattern of multiplication or division, whichever one you decide to go with. Let's run it, make sure that it works. Okay, so either way worked. We solved the puzzle. Just depends on which one you want to go with. Okay, let's go ahead and go on to number 12. It's a challenge. I think we can do it. All right, take what we've learned about for loops, try to solve this problem. We might have to go through it a couple of different ways. Now, this one looks kind of similar to the last one, where our movement and our collecting, our get nectar, coordinate with one another, okay? So let's start with our for loop. We won't set our values just yet. We again need to turn. This time, I think we're going to need to turn right because we're facing the opposite direction. Okay, we would move and we would get nectar. All right, and let's put our loops. We already know that we're going to move multiple times and get nectar multiple times. So I'm just going to go grab these repeats. And you can certainly do it a different way if you like. Okay, let's see what our pattern is. So first of all, we're going to move 1, 2, 3, 4, 5, 6, 7, and collect 14. Then we're going to move 1, 2, 3, 4, 5, and collect 10. All right. What we learned with the pattern earlier in number 11.
Is slightly cold. You may want to bring a jacket with you. Thanks.
All right. Was that it was based on multiplication, that they coordinated with each other through multiplication or division, whichever way you looked at it. So we're going to move 7 and collect 14. 7 times 2 is 14. So I think that's the math block that we're going to need to use. All right, so if we use the movement as our counter, we would start at 7. So we went 7, then 5, then 3, then 1. That's a slightly different pattern, isn't it? So we would end at 1 and decrease because we started a higher number. We would decrease by 2 because it goes 7, 5, 3, 1. Okay, so the counter variable follows our movement. So we just need a variable here for counter. And then we'll grab a math block for the second part. And pull out that first one. We want it based on the value of our counter. So counter times, and doing it this way, we would do 2. Okay, let's see if this solves the puzzle. Okay, I'm going to hit try again, and I will show you how you would reverse it again if you wanted to do it with the collecting instead. All right, so if we're counting on collecting, we would start at 14, and we would go down to 2. And what's the difference between 14 and 10 and 6 and 2? It's decreasing by 4 each time. Okay, so we would switch these two. Counter would go in the nectar, and then this math block would go in here. But instead of timesing by 2, we want to divide by 2. Because our counter will start off at 14. 14 divided by 2 is 7. That's the number of times that we need to move. So let's run that through too. Okay, so both ways work, and just depending on which one you want to use, but either one will solve it. Okay, so 13. All right, we can do this. Let's go ahead and get started with our math block. We're going to, so our loop is counting down, and we learned that in the last one, and the last two actually, where we've done it both ways. We can either increase going up or we can decrease. All right, so if we pull in our for loop, and we want to collect. So this time the movement is not also changing. There's no pattern here. It's a stair-stepper pattern, which we have done before. So we will add in those movements in just 1 second. Let's figure out our increment. We start at 15 first, and then we decrease by 3 each time until we get to 3. So we would set up our for loop starting at 15, going to 3, and decreasing by 3. So first of all, we would turn. And I think we're going to want to turn left. We can switch it if we need to later. Okay, then we would move. And then we would turn right this time because it flips back and forth. Move again. And now this is where we would do our collection. So we need to grab a loop first. Grab our variable counter. And get nectar. Okay, let's see if we got the movement right. Okay, all right, hopefully that was easy enough to follow along and you understand how to work with for loops. We do have a couple more lessons to go over, but for now that is lesson 22. Thank you so much for being patient and following along.